back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing developments in science, things that'll touch our lives and change the way we view reality itself. And with us today to challenge our belief in reality is Dr. Donald Hoffman. He's a professor of cognitive science at the University of California at Irvine, and he's the author of a new book called The Case Against Reality: Why Evolution Hid the Truth from Our Eyes. Now, you may say to yourself, this is crazy stuff. I mean, what? The case against reality itself? I mean, we have an expression, what you see is what you get. And seeing is believing. But is that really true? I mean, has evolution given us a brain that takes shortcuts, convenient shortcuts in order to rapidly assess dangerous situations? Or is what we see really reality? So once again, today we're going to ask the question, does the brain take shortcuts and give you an abridged, simplified version of reality, so what you see is not really what you get, and seeing is not really believing? So once again, with us today is Professor Donald Hoffman. The book, with a controversial title, is called The Case Against Reality: Why Evolution Hid the Truth from Our Eyes. Now, Donald, tell us a little bit about how you, as a young kid, first got interested in science, psychology, and eventually cognitive science.
Well, as a teenager, I started playing around with programming in the 1970s and started to see the power of programming in the early days of programming. And I was also interested in philosophical questions about perception and reality, and also the question that came up to me after programming a bit was, are we machines? Are people just machines, or is there something more to us? And I wanted to actually try to understand that question, and not just philosophically, but more rigorously. And so I went to UCLA and took a bunch of classes that were involving computer science, mathematics, and psychology, and then went to MIT and worked in the artificial intelligence lab and what's now the Brain and Cognitive Science Department, trying to get as rigorous an understanding as I could of what machines can do in artificial intelligence and what people are in the Brain and Cognitive Sciences Department, and then trying to put them all together to understand our place in nature and the nature of human existence.
Okay, now when we look at a computer screen, we see icons. Now, these icons are not really reality, but by clicking it, we can then access enormous amounts of information painlessly by using these little icons. Now, are you saying, therefore, that the brain uses these little icons to represent very complex reality features, and we take shortcuts constantly?
That's right. There's good evidence that throughout nature that animals use tricks and heuristics and shortcuts to just get through the day. The idea is to get enough fitness payoffs to stay alive long enough to reproduce. And you can think about the evolutionary framework as like a video game. In a video game, what you're doing is trying as quickly as you can to get as many points as you can at your current level. If you get enough points quickly enough, then you get to the next level. Otherwise, you die and you have to put in more money. And in evolution, if you're collecting fitness payoffs, if you get enough fitness payoffs, then you don't go to the next generation, the next level, but your offspring, your genes get passed to the next generation in your children. And so anything that's distracting you from payoffs will be a distraction from the real game here. And so evolution has shaped us and our perceptions to help us to find payoffs, and that turns out to be very different from finding the truth.
And talk about finding the truth. I was once part of an experiment myself. I was shown a videotape of a basketball game, a very simple rapid-fire basketball game, and the goal was to count the number of times the ball exchanged hands. So as the test went on, I had to concentrate to calculate exactly how many times the ball changed hands. Afterwards, I was shown the videotape once again, and there was a huge, ugly black gorilla walking in the middle of the basketball game, and I didn't see that gorilla at all. So how is it possible that I can watch a basketball game, count the basketball as it goes back and forth, and miss this gigantic black gorilla sitting right in front of me?
Yes, that's called, it's called attention blindness. And it turns out that we think that we have full resolution vision throughout our whole visual world, that we see all of the world in high reality. In fact, you only see a small disk about 2 degrees in diameter, which is roughly twice the width of your thumb at arm's length. A little disk about, the radius of your thumb, that's all that you have really high resolution vision in. And so we move our eyes around to put that high resolution vision on different parts of the world where we might get, information that's relevant to our fitness. And so things that we don't pay attention to, we either miss altogether or only get very, very vague information about. So we're under the illusion actually that we see reality in great detail. In fact, we have only great detail in a small disk of radius about 1 degree. So it's a lot of things that are surprising about our perceptual systems.
And speaking about consciousness, epileptics sometimes have to have the connection between the left and the right brain cut in order to stop them from having these debilitating seizures. But as I understand in your book, once you cut the connection between the left brain and the right brain, 2 distinct personalities can begin to emerge. One personality could be an atheist. The other personality could be a believer. And you can imagine what happens if one half of your brain is Republican and the other half of your brain is Democrat, and you're asked to go to the polling booth to hit the switch. You have an argument between your left hand and your right hand in the voting booth. So is that really true that in split brain situations, 2 distinct personalities can gradually emerge?
Yes, this is research that's been done by Mike Gazzaniga and others, and also a friend of mine, V.S. Ramachandran, who studied some of these patients. And they do find that the 2 different hemispheres first can have very, very different contents of consciousness. The left hemisphere might be aware of the word ring, and the right hemisphere might be aware of the word key, and neither hemisphere is aware of the word that the other hemisphere is aware of. And so they can even play 20 questions with each other. The left hemisphere and the right hemisphere can play 20 questions. The right hemisphere has a word, and the left hemisphere has to guess it, and it doesn't know, so it can ask questions. And you're right that even in some patients, they've gotten clear evidence that in one guy, the left hemisphere wanted to be a draftsman, and the right hemisphere wanted to be a race car driver. So very, very different desires there. And as you mentioned, there are theological differences, too. I believe in one person, the left hemisphere, this is a study by V.S. Ramachandran, the left hemisphere, I believe, is a believer in God, and the right hemisphere is an atheist.
Welcome back to Science Fantastic with Professor Michio Kaku. And the guest today is Professor Donald Hoffman, author of a new book with the outrageous title, The Case Against Reality. That is, what you see is not necessarily what is. Why evolution hid the truth from our eyes. Now, you have one chapter in your book where you talk about the results of evolutionary psychology, and the whole question of beauty and attractiveness comes into play. Madison Avenue, of course, makes millions of dollars on the question of beauty and the perception of beauty. But it goes back to the question, well, what do women want? And what do men want in a relationship? Now, Sigmund Freud asked that question, and he couldn't come up with an answer. What do women want? Now, what you're saying is that in evolutionary psychology, there is a hidden agenda, that our brain, as a byproduct of evolution, wants certain things that we're not really aware of. So what about the question, what do women want, what do men want, and what does beauty have anything to do with it?
Yes, so from an evolutionary point of view, attractiveness, when we look at a person and find them attractive, what's going on is a very sophisticated computation. We're evaluating dozens, perhaps hundreds of different clues, like the smoothness of the skin, the shininess of the hair, features of the eyes, of their voice, the symmetry of the face. And what we're doing is we're evaluating unconsciously and in less than a second we're evaluating the reproductive potential of that person. That is, what is the probability that that person is healthy and could bear or have raise kids? And again, it's not conscious. We're not consciously, asking that question, but it's the unconscious computation that's going on. And the end result of that is just our feeling of attractiveness. If they're very, very attractive, that's because we've estimated that they have, high reproductive potential. Now, of course, this is just the initial hit that we get when we talk with a person or first meet them. There's much more to relationships than that initial hit, but it's quite interesting to understand what's going on in that initial hit.
Well, we had one evolutionary psychologist on Science Fantastic who said that, well, what do women want on average? Because, of course, everyone's different. But on average, what women want is men with resources. That is, they're successful. They have enough money to sponsor their children and therefore propagate their genes. And what do men want? Men want women who are healthy, have hourglass figures, are youthful, because they can also have children and propagate the species. So are you saying, therefore, that there's a hidden agenda, that what our genes really want is to simply propagate themselves into the next generation, and therefore there are two different strategies to do it. Women look for success, and men look for health. What are your thoughts?
That's right. That's exactly what the research shows us, is that men are looking for youth and health in the woman, because that's the critical thing that during the Pleistocene, when we seem to have evolved many of our cognitive and perceptual strategies, that was a time from about, roughly 1.9 million years ago until about 10,000, 12,000 years ago. So during that time, the resources that a woman brings to the table weren't so critical, but the resources a man brings to the table were critical during that time. And so women were shaped by evolution to find men attractive who had higher social standing and more resources, which are correlated. And men and women are both shaped by evolution to prefer youth, but the shaping is far stronger in men, because women's reproductive span is curtailed more quickly than a man's. And so the selection pressures on men to prefer youth are actually stronger than the selection pressures for women, although both have selection pressures. So, and it also, even depends, on the time of the month for the woman, what she finds attractive. So it's complicated, but it seems to be that it's all, again, it's not a conscious strategy necessarily. It's what the genes have shaped us to just find attractive or not.
Now, some people say hogwash because you can't test it. These are events that took place thousands and thousands of years ago with our ancestors in the forest. But some people say no. In a university setting with college students, you can actually perform experiments on them to test some aspects of evolutionary psychology, starting with things like the eye. So explain to us the iris and the eye and the question of attractiveness.
Yes. So I noticed in looking at photographs of people from infancy to old age that there's a ring around the iris. If you look at the iris is the colored part of the eye, and right where the colored part of the eye meets the white of the eye, in many people you'll see a ring there. It's called the limbal ring. And I noticed in photographs that it looked statistically to be thicker and more distinct in infants on average than in older adults. And so I figured that that's an evolutionary cue to youth and health. So I predicted on evolutionary grounds that people would be more attractive if they had more distinct and visible limbal rings. And so we did experiments where we would show a bunch of faces where it was the same face side by side. On one side, there was no limbal ring, or very little limbal ring, and on the other side we had a nice distinct limbal ring. And we would ask people to just say which face was more attractive, and they would look at us and go, well, they're exactly the same face. There's nothing different. And we say, just humor us. Just pick one that looks more attractive. And what we found was that they statistically were far more preferred the ones that had the limbal ring, even though they had no idea what was going on there. So we found this both in men and women, and over a wide variety of faces. And then I also noticed that in, again, pictures of people from infancy to adulthood, that the iris itself, the colored part of the eye, is a larger proportion of the eye in an infant than it is in an adult. It could be almost 90% of the visible eye in an infant. and about 41% in an adult. So once again, it looks like the iris size is a signal of your age. And so I predicted that in women, because men prefer younger women, they like youth in women, that if we took a woman's face and expanded her iris just a little bit, that she would be more attractive. And we tried that, and it worked. So this is a case where we're using evolutionary principles not to make, just so stories about what happened a million years ago. I'm making new predictions that we can go test in the lab today.
Well, we had one psychologist on the air who said that on a blind date, a man cannot do a blood test on a woman to find out how much estrogen is in their blood in order to see if they can have healthy children. So you need markers that can rapidly tell you how much estrogen is in their blood, and you do that by looking at three things. One is chin. The chin has to be triangular and small. Second, the lips. The lips have to be full, and the nose has to be, again, proportionally shaped, and of course the eyes, as you mentioned. And these are estrogen markers that allow you to rapidly calculate in shorthand how much estrogen is circulating in the blood of the women that you're dating. Now, is that all nonsense, or is there some truth to it?
Oh, there's some truth to it. We genetically, we need to find out, as you say, the health of the genes and also the hormone levels of the person to see if they're really going to be able to bear kids and raise kids. But as we can't do blood tests, so we have to look at cues in the body itself. And so estrogen caps bone growth, so it makes for smaller bones, like as you said, the smaller chin. And it also puts fatty deposits on the lips and the upper cheek and so forth. So by looking at the shape of the face and the overall shape of the body, one can estimate the estrogen levels, and also, in the hourglass shape, whether the female has enough of the long-chain polyunsaturated fatty acids that will be needed to actually build the healthy brain in an infant. So, again, these aren't the things that are on a man's mind consciously, but this is all wired into us unconsciously and what we find attractive.
Now, some critics may say that all this is nonsense. It's a byproduct of a Western culture that believes in male domination. And, it's just basically Western culture magnified with pseudoscience. But what happens when you take these results overseas to analyze other cultures, other situations where we don't have the, quote, contamination from Western standards? What happens then?
Yes, so it has been found by a number of researchers testing the cross-cultural aspect of this, is that they've tested in African countries, of course Western countries, and then also in Asian countries, and they find that this is a universal property, that men prefer women whose waist-to-hip ratio is about 2 to 3. That is that the... Okay,
let's take another short commercial break, and after the break we're going to continue a discussion of this new book, The Case Against Reality. Science Fantastic with Professor Michio Kaku. Once again, our special guest today is Professor Donald Hoffman, Professor of Cognitive Science at the University of California at Irvine in California. And the book is called, quote, The Case Against Reality. A rather outrageous title, but, what you see is not necessarily what you get. And the subtitle is Why Evolution Hid the Truth from Our Eyes. Now, as we said before, there are critics of this theory. Critics of the theory say that all this happened millions, thousands of years ago. No tests were performed, and the tests that are performed are done in Western cultures. So explain to us again what happens when we go to other cultures analyzing the question of perception, beauty, and what women want and what men want.
Right. What we've found is that, for example, in estimations of the most attractive waist-to-hip ratio, that is universal. It's not just in the United States and Western European countries. It's also in Africa and Asia. So that seems to be a universal feature of male ratings of female attractiveness. With the body mass index, it's pretty interesting. Body mass index is an estimate of how much you weigh compared to how tall you are. And if you have a higher body mass index, that means that you're a heavier person. And there it turns out that there is variation across the world in what men find most attractive in the body mass index, but some research indicates that that may be due to the amount of food that's available and the possibility of famine. If you live in a place where famine is a serious possibility, then men prefer women with a higher body mass index. They're going to be more robust in that very difficult situation. But in areas where there's not famine, then men will prefer a slightly lower body mass index.
Now, right now, there's a controversy on social media, on the Internet, if you follow it, because a series of very well-established men in Hollywood are now marrying young women who are one-third their age. An example of a May-December marriage where the man has resources, is successful, is filthy rich, and the woman is young, has a nice figure, and can bear children. So are you saying, therefore, that this is good, bad, or this is just what is, rather than a statement of ethics and morality?
Right. The question of morality is a very interesting one from an evolutionary point of view, but from evolutionary psychology, these men and women are actually following the programs that are wired into us. Of course, the programs are very, very complicated. It's not just one little algorithm we have. There's lots of interacting algorithms. But in the case where an older man with lots of resources is marrying a younger woman, that does fit in with this evolutionary algorithm. The issue of morality more generally is very, very difficult from an evolutionary point of view. So, for example, in the case of humans, murdering your brothers and sisters is very, very bad. I mean, that's just nothing we want to do. But in the case of a bird called the blue-footed booby, siblicide is always happening. So every time the mother lays eggs, she has two, and the first thing the two chicks do when they hatch is fight to the death, and she doesn't stop them. The one pecks the other to the death or puts out in the sun, and she doesn't stop them. She killed her sibling. And apparently in that situation, their niche does not have enough resources to successfully raise two chicks. And so evolution has this quandary. It's either extinction or siblicide, and the choice is siblicide. And they have two chicks to find out which one will be the most fit, and it fights to get into the next generation.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Professor Donald Hoffman, Professor of Cognitive Science at the University of California at Irvine, author of a book with a rather outrageous title, The Case Against Reality. What you see, the colors, the shapes, the smells, are they a representation of reality? Or is your brain fooling you? Is your brain simply taking hundreds of shortcuts in order to make you survive so that you can rapidly respond to very complex emergencies and complex situations? So once again, the book is called The Case Against Reality. Well, when we left off, we were talking about what is versus what should be. Some people say, well, yeah, maybe evolution did give us all these instincts that men want women who are young and have an hourglass figure, that women in turn want men who are successful and have resources. But can't we rise above that? Do we have to obey the laws of the jungle? What are your thoughts?
Well, I think that we have these innate responses that are wired into us, but we also have the ability to look and make decisions in light of other considerations that we find important. So for example, one important aspect of relationships is what's called the parental investment in sexual reproduction. When you have sexual reproduction, one of the parents may require more of their effort and time to raise the offspring than another. That's called the amount of parental investment. And it turns out that the sex with the greatest parental investment will be the most choosy sex, and in terms of choosing partners, and the sex with the least parental investment will be the least choosy sex. And so in Homo sapiens, in our species, the females have the greatest parental investment. They require, to be pregnant for 9 months and breastfeed and so forth. Whereas men, it could, at a minimum, it could just be a few minutes is the only investment that they make to successfully have offspring. But it turns out that it's not just male versus female, in certain species, the male actually raises the offspring. So in that case, where the male is actually raising the offspring, then the female has to is the less picky, and the male is the more picky one. So we have lots of these different parameters that are going around, and we have various strategies that we can choose. And the strategy of being with one partner for a lifetime and raising just a few offspring is a very, very healthy strategy. But also, just from an evolutionary point of view, a strategy in which you have many partners and less investment can also work. But in human society, so both strategies happen, and we tend to put moral values on it. But in other species, right, both strategies are going on, and we don't put a moral value on it. So this again raises the deep question of what is the ultimate basis of right and wrong.
Now, some people think that men are shallow. That is, they look at superficial features. They're not very deep. While women are much deeper and coy. They have to be very careful because, well, men will lie to them. And they have to have a good sense of character judgment because men will lie to them to get what they want, while men tend to be shallow because, as you said, their investment is very, very small in a relationship. So you think, therefore, that this is really true in relationships, that women are more coy because they have to be more choosy because they're stuck for 18 years with a kid, while men can be flippant and superficial. What are your thoughts?
Right. So this does seem to be, again, an example of that parental investment idea, that women do have the greater parental investment. And so a woman who is not careful and not choosy risks making a mistake that's far more costly to her in terms of her reproductive potential than it is for a man. So as a result, women are just programmed automatically to be more careful in general. I mean, this is all statistical, and there are individual differences, but to be more careful in their choice of a man, to find a man who has not only a good genetic, composition, but also will have other qualities that they can bring to the table. They'll be faithful, they'll stick with her, they'll provide resources, and so forth. So yeah, it's for men. It seems, in a way, it's a bit simpler. It's youth and health, and those are dominating.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, if you want to find out more about Science Fantastic, go to my website. Website is mkaku.org, mkaku.org. I've written 4 New York Times bestsellers, and we have 3 million fans on Facebook. But today we're talking about, quote, the case against reality. Did you know that some psychologists think that our perception of color, of space, of time is in some sense incorrect, that the brain takes shortcuts even with our perception of color, smells, space, and time? Let's break it down now. Now, when you see a color, you only see really 3 colors. The primary colors. Our retina can only see 3 colors, red, green, and blue. So in some sense, you've never really seen yellow. You've never really seen brown. They are mixtures of those 3 primary colors. And so in some sense, the brain is taking a shortcut. There's so many colors, thousands of colors, in fact. Brain can't possibly process them. So it takes a snapshot, 3 colors, and then gives you the illusion that you're seeing purple as it really is. So what are your thoughts about how the brain tricks us?
So, yes, we definitely channel the wide range of electromagnetic radiation, all the different frequencies into, only 3 channels. So there's this, thousands and thousands of possibilities. We stick them through 3 different holes, and that's all we've got. 3 different receptor types, red, green, and blue, long, medium, and short, we call them, and then also the rod system. But pigeons have 4 color systems, and some creatures, like the mantis shrimp, has more than 10. So different creatures will have different capacities, different number of channels for processing color. We're not anywhere near the best by any means on that. And it does seem to be a general feature that that we're not seeing reality as it is. We're seeing something very, very different. The way I like to think of it is like the desktop interface on your computer. And if you're writing an email and the icon on your desktop for your email is blue and rectangular in the middle of your screen, does that mean that the email itself in your computer is blue and rectangular and in the middle of your computer? Well, of course not. Anybody who thought that is misunderstanding the point of the interface. It's not there to show you the truth. It's there to hide the truth and give you simple eye candy that lets you control the truth, which in this metaphor is the circuits and software and voltages, without having to know what's going on there. And if you had to toggle voltages to craft an email, your friends would never hear from you. And that's what evolution has done for us. It's given us perceptions that are a user interface. So three-dimensional space is just like our three-dimensional desktop, and physical objects are just like three-dimensional icons in that desktop. It's like a 3D virtual reality that we've gotten that hides the truth and just lets us do what we need to do to stay alive. So seeing the truth will actually make you extinct. Not seeing the truth, having the right interface, will help you to stay alive.
Now let's talk about the question of space and time. Now, I'm a physicist, and most physicists bristle at the idea that if a tree falls in the forest and there's no one there to listen to the tree, then, well, maybe the tree didn't fall in the forest. And it gets into the whole question of consciousness, perception, space, and time. But I think most physicists would say that, well, the dinosaurs walked the earth before humans. There was a reality before consciousness, that is, human consciousness evolved. But well, let's talk about space and time. Optical illusions tell us that our conception of space and time is faulty. That's why we go to science museums to watch these optical illusions. But does that mean, therefore, that maybe reality itself is an illusion? What are your thoughts?
Yes, it's very well received within the field of cognitive science that we construct what we see, that we construct our perceptions of space and time and objects. Most of my colleagues think that our constructions are in fact faithful reconstructions of reality, so that when I look up and see the moon, what I'm seeing is a faithful representation of something that really exists and resembles in many respects what I'm perceiving. And what I'm arguing is that in fact space-time itself is just a data structure that we create that represents fitness payoffs, and it's not there to resemble a pre-existing space-time. And what we call physical objects are also just data structures that we create on the fly. Think about having a virtual reality world where you have a headset on and say you're playing an auto racing game. So you see your steering wheel, you look to the right, you don't see the steering wheel. You've deleted the steering wheel because you're no longer rendering it. Now you look over to the right, you see a car, and you create the car. Then you look away, and now you've uncreated that car. Every time you look back, you'll see the car, but you're only creating the car when you look at it. There's no real car because this is all just virtual reality. And that's what I'm proposing is happening all the time. We have a headset on. Evolution gave us a headset. Space-time is the 3D format of it, and physical objects are fitness payoff representations that we render when we look. So I look at an apple, I create the apple and the fitness payoff. So I look away, and I garbage collect it. I throw that away. But when I look back, I'm interacting with some reality, and I then come up with the symbol of an apple. So that's just my Homo sapiens specific representation of fitness payoffs, and it doesn't really tell me the truth. It just tells me what I need to do to stay alive.
Well, I'm a physicist, and physicists believe in experiments. So let's do an experiment. Let's jump off a cliff. When you jump off a cliff, chances are gravity's going to take over, and you're probably going to die as a consequence. And that's not a question of subjective reality. So are you saying, therefore, that human space-time is subjective and prone to errors and so on and so forth? Human space-time, but physical space-time is objective or more objective than human space-time. You have 10 seconds to answer that question. Sorry about that.
There is a reality that's objective, but it's not space and time.
Okay. Well, unfortunately, we have run out of time. Once again, you've been listening to Professor Donald Hoffman, author of an exciting new book called The Case Against Reality, Why Evolution Hid the Truth from Our Eyes.